So here we want to derive the formula for the derivative of sine inverse. What we could do is we could go about it implicitly, since we know that sine inverse of x equals y if and only if x is equal to sine of y. We can then use the derivative of x equals sine y to implicitly solve for y prime. So let's take the derivative of each side with respect to x. On the left side we get 1 equals the derivative of sine on the right side will be cosine of y times y prime, because we're solving implicitly. So therefore y prime will be 1 over cosine of y. And in order to get this back into the x variable, we want to think now, how does the cosine of y variable, how can the cosine of y function be written in terms of the sine of y function, so that I can return to the x variable. So we can just remember a fundamental identity that sine squared y plus cosine squared y equals to 1. So if I isolate cosine in this equation, I can write cosine squared equals 1 minus sine squared. So cosine of y is equal to the square root of 1 minus sine squared y. Actually, we may want to think of this as plus or minus the square root. But in this case, because cosine takes on only positive values in the range when this inverse function is defined. So remember here that y has to be between negative pi over 2 and positive pi over 2. We know that cosine is actually positive for those values, right? So this will be equal to the positive square root of 1 minus sine squared. So therefore this will be 1 over the square root of 1 minus sine squared. And then putting x in for sine of y, we get our formula. Y prime is equal to 1 over the square root of 1 minus x squared. So that'll be the derivative of sine inverse. And we notice that it's differentiable for any value of x between -1 and 1, but not at the endpoints. So let's practice with this particular example here. We've got a function f of x equals the sine inverse of x squared minus 1. What would our domain of this function be? Well, remember, in general, sine inverse of whatever I put in here has to be between -1 and 1. So in this case, we want to ensure that x squared minus 1 is between -1 and +1. So if we try and solve this inequality out, we get, let's see, if I add 1 to both sides, we get x squared is between 0 and 2. And therefore here we can assume that x without the square on it is going to be between negative square root of 2 and positive square root of 2. Okay. And therefore the domain of our sine inverse function of x squared minus 1 will be the interval from negative radical 2 to positive radical 2. Now let's find f prime. So remembering our formula for the derivative of sine inverse, it'll be 1 over the square root of 1 minus x squared. In this case, we got sine inverse of x squared minus 1, so we're going to replace x with x squared minus 1. So it'll be 1 over the square root of 1 minus x squared minus 1 squared. And then we're going to multiply, because of chain rule, by the derivative of 1 minus x squared. So we're going to multiply by negative 2x. And so this will become negative 2x. And then downstairs we can look at the square root of 1 minus x squared minus 1 squared. Maybe that could be simplified a tiny bit. Let's see, I could write that as 1 minus, when I expand this out, it'll be x to the 4th minus x to the 4th minus 2x squared plus 1. And then a tiny bit of simplifying there. I think leaves me with, let's see, the 1 minus 1 here will go away. So I got 2x squared. This changes to plus x squared there, because plus 2x squared, because the minus gets distributed, and then minus x to the 4th. Now looking at this, it appears that our domain of this function will contain the same values that we had in the domain of our original function, except now we don't want to include the endpoints, because we notice that at negative radical 2 and at positive radical 2, we're going to get 0 in the denominator, right? So for instance, if I substitute in plus or minus radical 2 for x, you're going to get 0 in the denominator. So it's undefined at the endpoints. So it's not differentiable at the endpoints, but it is differentiable in between. So we'll get a positive value inside the square root whenever x is between those values. So it'll be the open interval from negative square root of 2 to positive square root of 2.